Okay, so today in class we went over the first two examples from Lesson 1.7. And if you'll recall, Lesson 1.6 was representing functions as equations and tables. And today we're going to represent functions as graphs. Okay, so we're just going to kind of breeze through these first couple of examples. If you were here in class, you can go ahead and fast forward until we get to example 3. That just goes to show that I want you to be able to go back and forth between any of these ways when given one and the other, okay? We also reviewed a coordinate plane, talking about the fact that they are separated into 4 quadrants, starting here going counterclockwise. To get to the positive quadrant, you do a right and up, left and down are your 2 directions. And so what I want to do is get this function, this table, onto a graph. And if you'll remember, your x is your input and your y is your output. So we make ordered pairs, basically, and plot them on our tables here, or on our graph. So there's our point 1, 2, 2, 3, and 4, 5, and so on. Okay? We talked then about giving you a function and just the domain and asking you to graph that, okay? Well, we know in order to graph right now, we need a domain and a range. So what we have to do is take this graph, or of this equation here, and enter our domain into it. So we enter our domain, being get what we were given, and then we input this into the x spot, take half of it, and that shoots out, which was why we call it your output, your y value. So half of x when x is 1 is 2 is 1. Half of x when it's 4 is 2, and so on. And then once we have our range, then we can go ahead and plot those points right there. Okay, so that was the first example we covered. The second example we covered had to do with, where are we at here? Example 2, and we were given this table, and it says the years since 1997 would mean that year 0 is 1997, and year 1 is 1998, and so on. Okay, and this happens to be the average SAT score. So I'm at 511, 512, 511, and then when we plot this, we have our years since 97 here on our x-axis, our score over here. These are our order pairs that resulted from our table. And what we're looking for then is what is the trend in the average SAT score over years. And that's really what trend means, is over the years, the trend is increasing, which means the scores are generally increasing. A trend does not mean that every single point has to increase. So, for example, it went down from year 1998 to 1999. But overall, the data is increasing, okay? And that's where we left off in class, okay? So the new notes, starting with example 3, we're writing a function rule for a graph. And we talked about how a function rule really means an equation, okay? So if I were to write a rule for the function represented by the graph, I have to put this here. So I'm now asking you to write a function for that. So given the graph, how could you write the equation for that? So basically we're going to kind of work backwards. If I was given the function like I was in example 1, I would make a table and then plot the points on the table. But here I already have the points plotted, so instead of putting them, let's pull the points out. So from this, it looks like we have 1, 2, 2, 3, and this is the table that results from that graph. Okay? So step 1, make a table from this graph. And you can pause this video at whatever point you need to. So these are the points that I pulled from there. Then we go ahead and we do what we know how to do and find the relationship between the inputs and the outputs. And for every input that goes up by 1, the output also goes up by 1. But we have to remember where we started. So the relationship here is for every one this goes up 1. Okay? But if we also were to, let me get a pencil, find out what our initial value would be. Our initial value would be 0, 1. Okay? So let me just get this table here. So we have y and x, 1, 2, 3, and then 2, 3, 4. So as this goes up by 1, we find that that is our slope, which is our rate of change. Okay? Which is 1. And our initial value, just like we do in our bell work, is, and if it's not there, then you need to put it 1. Okay, of course. Y equals mx plus b, x plus 1. Okay? So is every one of these y values the x value plus 1? Yes, it is. If the x value is 3, add 1 to it and you get 4. Okay? All right. Let's take a look at example 4. You're being asked to analyze a graph. This graph shows guitar sales, okay, in millions of dollars for a chain music store for 1999 to 2005, okay? This is something new, I know, but you're going to have to get used to it. This is the years since 99. So this is obviously year 1999. This would be 2000 and then 2001. Identify the independent and the dependent variable. We have not talked about that yet, so we'll save that for a day where I'm here in class. Describe how changes over this period of time have changed. So obviously the trend is increasing, okay? The independent variable basically is something like what depends on what? Does the sales depend on the years or do the year depend on the sales? As we follow this trend, this is showing that the sales are going up. I'm thinking we may not have you do that one. Let's take a look down here. Ways to represent a function. You have verbal, which we haven't really talked too much about just yet, equation, table, and graph, and these are the 3 that I wanted to show you earlier. Okay?